this lesson, we investigate what happens when we repeatedly multiply by a positive number less than 1. When we multiply by a positive number greater than 1, we end up with more than what we started with. This is called growth. When we multiply by a positive number less than 1, we end up with less than we started with. This is called decay. Let's begin by reviewing growth multipliers. Here's an example. In 2008, the price farmers received for a pound of almonds was about $1.45, then increased about 17% per year for the next several years. In what year did the price received first exceed $3 per pound? That's a pretty big increase. $3 is more than double $1.45. Well, 17%, that's equal to 0.17. But if we multiply by 0.17, all we figure out is how much the price increased by. But we want to know what the actual price is after the increase. So that's why our multiplier will equal 1 plus 0.17. So to figure out the price after a 17% increase, we just need to multiply by 1.17. Starting with $1.45 and repeatedly multiplying by 1.17, we can figure out what the price will be the following year. We see that the price of almonds exceeded $3 per pound in the year 2013. Notice that with a 17% growth rate, the price of almonds increased by more and more each year. We can write this type of situation as a recursive rule. In this case, start with 1.45, then multiply by 1 plus 0.17. Decay multipliers are different. Each time we end up with less and less when we have a decay multiplier. Let's see how they work. The price of a $100 purse is discounted 20%. How much did it cost after the discount? Well, we know that 20% of $100 is $20, so we're saving $20, which means the price of the purse was $80. Let's see how we can do that mathematically. We can multiply by 1 minus the discount. Or in other words, we can multiply 100 by 0.80. If we think about it, that makes sense, because we're going to keep 80% of the value. So we're losing 20% of the value, but we're keeping 80% of the value. So after the discount, the purse costs $80. Now what is the price if the store lowered the price another 20%? Well, once again, that would be 80 times 1 minus 0.20. So we're keeping 80% of the value of the purse because we're losing 20%. So after the store lowers the price another 20%, now the purse costs $64. Notice that the first discount resulted in a discount of $20. The second time we lowered the price by 20%, it only decreased by $16. So it declined by less, even though the discount was the same. Alright, moving on. Write a recursive rule to generate the sequence representing the price after repeated 20% discounts. Start with 100, and then repeatedly multiply by 1 minus 0.20, which is the same as repeatedly multiplying by 0.80. Let's practice finding multipliers for percent decreases. We'll do one together. After a 15% decrease, well, we'll still have 85% left. So our multiplier for a 15% decrease is 0.85, because we'll still have 85% left. Now it's your turn. Let's practice writing sequences with decay multipliers. We're going to find the first three terms of each sequence. In the first one, the sequence starts with 350, then each term decreases by 28%. Let's figure out the decay multiplier. 1 minus 0.28 equals 0.72. So we're going to be repeatedly multiplying by 0.72, because each time we're losing 28%, but we're keeping 72%. And we want to know what's left, not how much we lost. And those are the first three terms of that sequence. Now it's your turn. Your sequence starts with 2050, then each term declines by 6%. When we lose 6% each time, we're keeping 94%, so we repeatedly multiply by 0.94. Here's an application for you to try. The Great Western Emporium has a must-go rack. The price of each item on the rack is decreased by 10% each day until the item is sold. How many days will it take for a $45 jacket to be priced less than $20? Graphing is an important way to visualize the math around us. Let's make a graph that shows the daily price of the $45 jacket that is discounted 10% more each day. So day 0, the jacket was $45. After one discount, it was $40.50. We see that the graph gets a little bit less steep each day, as the value of the jacket was decreasing by less and less, because we were taking 90% of a smaller and smaller number. If we compare the graph of the daily price of the jacket, we see that it's not a straight line. The discount is worth less and less each day. In this lesson, we explored multiplicative recursion in situations that decay or get smaller. The key to working with these patterns is to subtract the percent decrease from 1 to get the constant multiplier.